everybody. This is Dr. Anna, and we are back with the second segment. And I finished the first segment with starting to tell you a story about me being in high school. As I mentioned, I was in a very special high school in Hungary. I already decided to become a geologist, so I went to a geology high school. A lot of our classes were geology related. I had mineralogy, I had physical, historical geology, paleontology. So basically, very much at the beginning of my high school years when I was 14, we had to look at the deep time. Um, my teacher at the time have told us that we have to imagine a million years in the Earth history, like one blink of your eyes during your lifetime. So that actually makes it really interesting if you think about it, because one blink of your eye in your lifetime is basically no time. So when you think of a million year, this is how you have to look at it from now on. You know, some people say that, oh, geologists know nothing. They don't even know exactly how old Earth is because they say between 4.5, 4.6 billion years. But if you think about that, zero point 0.5 and zero point 0.6 billion, that is 100 million years difference. And when you look at 4.6 or 4.5 billion years, 100 million is not that much. So we have to put it into that kind of perspective. Remember, 1 million year in geologic time is equal one blink of your eye in your lifetime. And that puts a different perspective here into the deep time. So I hope it's going to help, because it did help me a tremendous amount. So here is the way the American schools are trying to explain you the geologic time is that we compare the geologic time into one calendar year. So we would figure that from January through October, which is 75% of the Earth history, is basically completely obscured. Why? Because it's all metamorphosed and then metamorphosed again and metamorphosed again, because we learned some about plate tectonics. So whenever there is a continent collision, the rocks are extremely metamorphosed and then they melt again and they metamorphose again. So as you go through these cycles more and more, basically the original features of the rocks disappear. So we can say that about 75% of the geologic history is completely missing, obscured, it's gone. The first fossil which you can actually recognize appeared in mid-November. So just think about, like, we only have the last 1.5 months with fossils and full-blown toolkits for historical geology. And the extinction of the dinosaur occurred on Christmas Day. And Homo sapiens, which is us, came around at 11 p.m. on December 31st. So therefore, the human history is only just the last couple of seconds of the Earth history. So it's very interesting perspective. Probably some of you have already picked up a rock wondering how old could it be. And if you remember in physical geology, I do remember when we went to Fishburne Park, I picked up that red clay, shale, and I said it's about 450, 500 million years old. And some of you might have asked, how do you know? And it's interesting. If you're a geologist, if you become a geologist, you will have to learn this stuff, and you have to take it as that other geologists have used absolute age dating, and others have used the fossils to correlate the absolute ages into sedimentary rocks. And that's how they come up with their age. So when you take geology class in school, you will be told that these rocks are about 500 million years old, and we know because of this and this and this. And actually the science which works with the age is what we call geochronology. Geochronology. When you look at geochronology, we have two kinds of dating method. One is the relative dating, and the other one is the absolute dating. And we still use both of them. You cannot do one without the other. Remember, I mean, don't remember, I mean, you will remember because I will ask this on the test. The only type of rocks you can really well measure absolute age is igneous rocks. So everywhere else we use the so-called relative dating. I'm gonna learn about that in just 1 second. So the science of relative dating have started about 400 years ago, around James Hutton time. And the reason for the relative dating is because they didn't really know the exact age, I mean the absolute age. However, they could tell that things happened before or after. It's just like our lifetime, you know, like when you have, you know, that you have had your great grandparents, you know that they had 5 kids, the 5 kids had this many kids, and you can put the relative age of your family tree based on events which you know about, and you know which one happened before and which one happened after. And this is the same way with geology. You know, when you look at an outcrop, a rock outcrop, and you see how the layers are coming up after each other, then there is an igneous dike going through, you can kind of tell what happened when. So basically the relative age and the relative dating happens by geologists using the geologic principles we're going to cover in a minute, putting the geologic event together one by one. And this is historical geology, basically, using the principles, the geologic principles, and then using the absolute age dating, we will be able to put the events together one by one from oldest to youngest. And based on the relative dating, geologists come up with the so-called geologic time scale. And the geologic time scale is a very relative. It's based on the relative dating. And the names on the geologic time scale are location names. Usually they happen, these names come around based on the most representative section and the location of that representative section, like Jurassic, the Jura Mountain, or Triassic is the basin in France. The Cretaceous is also, it's either Italy, France, or in Europe, basically. That's where the whole thing has started. So this is the geologic timescale. This geologic timescale is strictly based on relative timescale. Now, on the right, you see the absolute age data, which was done much later. But at the beginning, we just had this timescale, the relative timescale, which doesn't really include any age, and it doesn't give you a sense of time. The biggest one doesn't mean that it's the longest time. It just means that the more detailed, the more we know about that stuff. So if you look at it, here we are, Earth is 4.6 billion years old, and if you look at the Precambrian, this is the smallest here. If you look at the Precambrian, this here is the smallest area. However, it represents about 75% of the Earth history. And if you look at the Cenozoic, which basically is just the last 66 million years, it's the biggest part of the geologic timescale. Why? Because we have a lot more detailed rocks which are not changed by metamorphosis, so we can actually correlate with them. The fossils are there, they haven't changed, they were good, and therefore this is what we know in more detail. And then it turned out, when they came up with the absolute age, that it's only 66 million years. And if you look at the whole Phanerozoic, this whole thing basically is only 540 million years, which is 0.5 billion. So if you think about the 4.5, 4.6 billion years Earth history, basically it's the last 0.5 billion years. So the 4 billion is in this low area right here. So remember, the geologic time scale is a relative time scale. It has nothing to do with the absolute age. This is based on the geologic principles. Now, the bad news is that you have got to memorize this, Not exactly this one, actually. There is this link which doesn't work anymore, but on Blackboard I will put up the real link, and I will also show it to you. We are a hybrid class, so we will meet in the lab. I'm going to show it to you exactly where it is and what you have to learn, but it's very important that you got to learn it. This is something which will be on your midterm, and it will also be on your final, so you will get 10% of your test twice with the time scale. And the one I will put the link up, I'm going to print it empty and you have to fill it up. It's very, very important that when you learn the time scale, you learn it from down up. Because, you know, your life started with you being born and it's going to end when you die. So basically, you want to go from the beginning to the end. So you have to start learning it from the bottom up. If you do it the other way, it's gonna be confusing. So please, 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 I couldn't go from up down. I couldn't. I only can say it from down up, and this is what I suggest you do too. There are some helps. If you go on the Blackboard, I posted a couple of websites where they try to help you with learning it, with making sentences from the first letters and stuff like that. I learned it when I was 14, so it was pretty hard. I suggest you print it out, print out the filled table, and put it to the bathroom next to the toilet where you sit every time. And whenever you sit down there, look at the table and just learn one more word. So every time, remember, every time you sit on the toilet, you learn one more word, you're gonna get there. Remember, this is very important. No one can pass my class without knowing the geologic time scale, because this is all about the geologic time scale. So the next thing we have to know is the geologic principles, and I already kind of went through a couple of them. And remember, it's going to be on the test. You will have to know all of them, and not just their name. You also have to understand them. And I will go through one by one, but I'm going to tell you here. The first one is the superposition, original horizontality, the lateral continuity, cross-cutting relationships, principle of inclusion, uniformitarianism, unconformities, and the faunal succession. So you have to know all of this. So let's start with the superposition. Superposition is simple. All of them are simple, actually. The superposition is that if you have an undisturbed sequence of sedimentary rocks, anywhere you go, if you see layers of sedimentary rocks, automatically you know which one is the oldest. Right here. And I mean, it says it right here. Obviously, the oldest is the one on the bottom, and it's logical. Why? Because that one was the first which settled down. What makes the layers settle down? What makes them go down? Yes, it's the gravity. So the gravity makes them lay down. So obviously, whichever laid down first was the oldest. That's very logical. Geology is extremely logical, don't you think? I mean, really seriously, you can learn critical thinking by learning geology. You can do reasoning. It's really, really cool class to learn, because this is nothing but logic, and it's very easy if you just understand it. The bad news is that you have to learn some basics, but after you learn the basics, you can actually come up with just about everything. Okay, so the second one is the principle of original horizontality. The principle of original horizontality will tell you that when you have sediment settling down, because of the gravitation, they will actually deposit horizontally. They will make horizontal layers, just like it shows right here. And the third one is the principle of lateral continuity. Don't forget, you have to know this, right? So the principle of lateral continuity, that just means, like, if you have a lake or a sedimentary basin, we will call them, then when the sediment goes in, it will actually, the layer will lay down horizontally, but it fill up the whole available basin. Like if you have a bucket and you pour sand in the bucket and there is water in the bucket, the sand will fill up the whole bucket, but it cannot go outside of the bucket. So in the bucket, the sand fills up a whole layer. That's original the lateral continuity, that's all. So the continuity may be disrupted by only later events, such as erosion. It could be a fault or something like that. This is the principle of cross-cutting relationship. When you have a sedimentary rock and it's cut through by an igneous dike, remember we learned igneous dike, that's just a low layer of igneous rock which cut through the layers. When you look at it, you know that the igneous dike has to be younger because the other rock had to be there for the igneous rock to go through. It's just like when somebody has a baby, you know that they had to do something before, and that happened before somebody got pregnant with the baby and had the baby. So these geologic principles are just like that. So you kind of logically can understand what happened before and what happened after. So if you have a problem like this, you know that the rock which is being cut through has to be the oldest, because it had to be there for those other things to cut through. And like on this picture, you see this layer, this is another dike, this cutting through this dike, so therefore this had to be there for this to come in. And the same here with this little one. The other two had to be there for this to come through. So the base rock is the oldest, and then this dike, and this dike, and this is the youngest right here. So it's very, very simple. It's easy to understand, and in the lab we will practice this. So don't worry if you feel like, oh my God, I'm lost. You're not really lost. It's very easy, and I will explain it again in the lab if you need to, or you've just watched this slide again. The next principle is the principle of inclusion. Like if you were on the beach and you see pebbles in the beach, and the pebbles are being included in the next layer logically. So you know that the pebbles have been another type of rocks before they become pebbles. So therefore, if you have a rock with inclusions in it, you got to understand that inclusion is always older than the rock which includes them. So this is very important, that the inclusion is always older than the rock which includes them. That's the principle of inclusion. And the next one is the principle of uniformitarianism. And I already have talked about that. That is the present, which is the key for the past. And I'm going to stop the second segment right here and continue with the next one. I hope it's going to go up onto YouTube. I'll see you in the next segment.